microphone. I don't know what's wrong with it, but I'll be replacing it as soon as I can. It's almost unlistenable. I guess the good news is that really what you maybe want to look at is the calculations on Excel, not necessarily what I'm saying into the microphone. Let's look at a couple of announcements. Homework 3, that's due 2 days from today. And the hand calculation should be submitted as a PDF file. And the spreadsheet calculation should be submitted as an Excel file, so upload your actual spreadsheet. And then also write the answer to the question that you've solved by Excel on the same paper where you've done your calculations for the hand calculations. One Excel file. Yeah, what you should do is if there's multiple problems that you've solved with Excel, I recommend creating a different tab at the bottom for each one of the problems. So a different sheet for each problem. Other questions related to the announcements? Okay, we're going to continue playing around with Excel today and reviewing a few things. One of the problems that you've got on the homework assignment is a complex cash flow diagram that you're going to have to solve in steps, and then I ask you to solve it by the equation method. So we're going to do something similar today for the first problem on the in-class exercise. I'll demonstrate it by the, I'll have you calculate it by the factor method, which I'll also provide the answer to the factor method, but then I'll show you how we would have done it by the equation method. So they're very closely related as long as you've got the strategy figured out. So when I say strategy, what I mean is the ability to look at a cash flow diagram and visualize how you're going to break it up into multiple steps in order to find the present value or the future value or whatever the problem is asking. So here's an illustration of a cash flow diagram where we've got an annual series which is offset from time 0 by a year. So you see that there's no amount in year 1. And then we've also got here an annual series coupled with a gradient. So both of those are together. So when I say coupled by a gradient, what I mean is we've got every year 5,000, and then it's 1,000, 2,000, 3,000. So, you know, the separate arrows aren't shown here, but you can think of it as here's an A where the amount is 5,000, and then here is G is 1,000, and then 2G, 3G, and so it's an annual series and a gradient. So here's the strategy that I'd use to solve this one. First of all, I would find the present value of this annual series of inflows. Now when I say present value, maybe to be more specific, what I mean is a single lump sum amount that's 1 year prior to the first annual series payment. So it's not actually in the true present, which we know to be year 0. When you find P given A, that just moves the amount to 1 year prior to the first A. So you're going to use either the factor table or the equation for find P given A, but by P, what I mean is the amount in year 1, meaning 1 year prior to the first time we saw the annual series. Does everybody understand that step? I've sometimes called it like a quasi-present in past lectures. It's not the true present, which is time 0. It's just from the perspective of this annual series, P is 1 year before the first time we saw some amount. Okay, so my first step would be to find this present value, and then I do another step where I take it to year 0 with find P given F. So the first one was find P given A, and this problem says that the interest rate is 8%, and then we have n equals 3. So this notation of putting things in parentheses is just a quick way to summarize the operation that we're going to apply. So find P given A, That will give us this first red arrow. And then with the second step, I would say find P given F. So find P given F, I equals 8%, N equals 1. So I can either go to the factor table or I can use the equations and find out, like, what is this number? The ratio of P to A. I can also do the calculations, find out what's the ratio of P to F. And so this will be on the table, some number. So I'm going to give you the in-class exercise today that has the factor table on the back for the 8% interest rate. And we would find out P slash A, N equals 3, 2.5771. 2.5771. So what that means is P is A times 2.5771. So it's a ratio that then if you multiply by the known annual amount, that gives you the present amount. Okay, so that's the strategy for the inflows. The strategy for the outflows would be similar. First of all, I'm going to find some equivalent lump sum amount prior to the first annual series amount. So this is find P given A for the outflows. Let me label this inflow, which was the first two steps, and now outflow. Okay, so the third step is find P given A for I equals 8%, and N is, let's see, 1, 2, 3, 4. So N equals 4 for that one. Now, we also want to find out the lump sum equivalent of the gradient. So this second arrow represents the single lump sum amount where we've done P slash G, find P given G for I equals 8%, N equals 4. Now remember, on a gradient, we still say N equals 4, even if you only see the extra 1,000 kick in 1, 2, 3 times. So it's 0G, 1G, 2G, 3G. So N equals 4 for the gradient. Okay, so what would be my final step? Once I've got a lump sum equivalent of this annual series of outflows and a lump sum equivalent of the annual series of the gradient. Anybody see what the last step will be?
Just P over F.
Find P given F. Yes, so that we can move it to times 0. So we want to move the outflows to times 0. So here I'm going to have to write really small for 5, but it is find P given F, I equals 8%, N equals 6. Okay, so I'm going to turn you loose on this problem with the factor table. Let me hand out the in-class exercise. We're going to do this one on paper, and then we'll practice some additional spreadsheet stuff with the problems on the back side. So the factor table is on the reverse of the page. Does anybody need that QR code back on the screen? Everybody got it? On paper. many extra papers? There should be several, right? There's 63 enrolled and I printed 65. Let's see, here's one. How many more do we need? You got one? That's it? All right, so the first step, just to review, is you're moving the annual series to time 1. The second step is you move this quantity, which I've labeled as A. That letter is just to kind of designate so we can keep different times and amounts separate. So A becomes B when you discount it one additional year at 8%. So then the sum of the inflows taken to the present, the value of that's $26,247.51. Now, I haven't yet rounded off, and at the end there's a final step where we do round off, looking at how many digits were in the factors that were used. So you round off to the fewest number of digits depending on which factor you utilize. But then looking at the outflows, step 3 was finding quantity C, which is a lump sum equivalent of this annual series in years 7 through 10. Then finding the lump sum equivalent of the gradient, which is arrow D. And then step 5 is taking all of those amounts to year 0 as an outflow, and that's quantity E. And then the last step is to find the combined inflows and outflows and then round off. So you'll notice that I rounded off to 4 digits because a couple of the factors that we used were only calculated to 4 numbers. If we'd use the equation method and retain all of the precision in your calculator, then we could express this to the nearest penny, and we wouldn't necessarily have to round off at the end. So does anybody have any questions about either the strategy or the specific calculations in the solution that I've given you?
You're getting $11,000 annually. What is that outflow?
No, it's an inflow. So you're getting it in the future. The question is, how much what's the economically equivalent amount if you got a lump sum payment today instead of getting payments in the future? So it's still an inflow to you. It's just a matter of, do you want it now or do you want it in years 2, 3, and 4? Are there other questions? Okay. Well then, let's now take a look at future values. So, what if you had this cash flow diagram and it was asked to find the future value in year 16? So if you do have one of the in-class exercises, this is on the back side. If you've only got the solution that I handed out, you'll have to just go by what's on the screen here. Let's translate this into a cash flow table and find out the future amount in year 16. So down here, I've given you a reminder of what the column titles should be. We should have a column that says year, a column that's years until year 16, one that's amount, and future value of amount. So before I turn you loose, who can remind me what the purpose of this second column is? Like, why am I separately keeping track of how many years it is until year 16? What's the specific use of that?
Count down.
Okay, you're going to be counting downward, but why? Why do we need that amount?
Because that number is the years of the compound.
Pardon me?
That number will be the years that it will compound.
That's the number of years it'll compound. Right, so let's use the example of this 9,000 in year 1. How many years does it need to compound to get to year 16? It's not 1 year to get to year 16, it's 15. So if we have in year 1, $9,000, we also need to have some time reference that tells us how many years in the future that is n. So in the equation, the FV equation, it's going to prompt you with NPER, the number of periods. And you're going to use how many years it is until the future date that you're interested in the NPER field. All right, so let me pause from talking, give you a chance to, number one, translate the cash flow diagram into a cash flow table, and then start calculating future amounts. We want to know the sum total. Okay, so as a reminder, the way that we use the FB function, it equals FB, and then when you put in the parentheses, it'll begin to prompt you with what it needs to know. So first of all, it needs to see an interest rate. So up here at the top, I'm going to define an interest rate, 0.0625. And remember, we need to have the label in a different cell from the number. Otherwise, it'll give us an error message. You can't combine a string with a number. So equals FV, and click on the interest rate here. I'll lock the reference by pressing the F4 button, and then it'll put in those dollar signs. NPER, the number of periods. So how many years does it need to compound into the future to find the future value that we're interested in? So this 3,500 that's in year 0 needs to move 16 years to get over here to year 16. So I'm going to click on the reverse time column, skip over the payment field with a double comma, and then minus of the amount, put that into the present value. So it finds that 3,500 in year 0 compounds up to $9,232 in year 16 if each year it's compounding at 6.25%. Then we can double click to apply that same formula all the way down through, and then the total will be using the sum function. So it should be 61,157 and 18 cents. Did anybody else get that same number? Okay, good. I'll pause for a second, so if you haven't quite gotten to that point, you can catch up. Okay, so the next part of the question asks, what would the interest rate need to be for the total to be $100,000 instead of $61,000? So to answer that, I'm going to create a copy of this worksheet. You can do it down here at the bottom. If you right-click, there is Move or Copy. So I'm going to create a copy, and so I'll call this Problem 2 Part A, and then this one will be Problem 2 Part B. You can label them. By the way, it's probably best if you run Excel as the actual program and not through a web browser, because some of the tools like GoalSeek may not be available in the web browser compared to the full version that's actually running on your computer rather than running in the cloud. You just right-click on the tab, and then it'll bring up this menu, and you select Move or Copy, and then click Create Copy.
Otherwise,
infinite number.
Okay, so create a copy of it, and then what we're going to do is play around with the interest rate until the total is 100,000. So our goal, the objective here is change I until the total is 100,000. So we're going to do a goal seek. And if you don't have goal seek on your computer, you can do it manually just by interacting with this interest rate by typing stuff in. So you can type in, for example, 0.09. We're getting closer to 100,000. 0.1, 0.11, 0.15, all right, 0.18, too high, 0.17, oops. So the objective here is to change the interest rate until we find out what interest rate would give us $100,000. And so you can either toggle it manually or you can do goal seek. So up here on the data tab, under what if analysis, is a feature called goal seek. And our goal is going to be set the total equal to 100,000 by changing T1. You can click in there or you can browse to it, type it in, but when we click OK, it's going to change the value in cell T1 until it sees $100,000 in the target cell. Okay, so it finds that if we had an interest rate of 17.246%, then the future value in year 16 would be 100,000 instead of what we found in part A was 61,000 at 6.25%. So it allows you to play around with hypothetical scenarios. Let me show you the goal seek one more time. So what you do is on the ribbon across the top, we want the data tab, and then what if analysis, goal seek. And so where it says set cell, that's where we click on the total, because that's our objective, to 100,000 by changing. Now we click on the location where the number representing the interest rate is found and click OK. And so then it'll play around with things until the solution converges to the target we've identified. Oops, I should have said keep it. Okay, so the last thing on this class is using the rate function. So what if we wanted to know how to find the unknown interest rate that brings equilibrium between this cash flow that's in the table? Okay, so we've got an outflow of 45,460, and then we want to know what interest rate makes it so that it's economically equivalent to receiving inflows of 7,500. So we're going to use the function equals rate, and then it asks NPER, so it's 7. You can see that there are 7 payments of 7,500. So then comma, payment, 7,500, comma, present value, negative 45,460, and then close parentheses. It says 4%, but we can increase the precision that it's showing, and it's 3.735%. Will bring, if you're discounting the $7,500 each year to times 0 at that rate, then the inflow and the outflows are equal. Okay, so hopefully that in-class exercise gives you a little bit additional information for the homework that's due on Wednesday. Remember to submit that to Blackboard before noon, and then we'll continue on with some new material on Wednesday.